Hey, good day everyone. So we are now in quarter 3, module 5, lesson 3, differentiation rule. This is the continuation of the differentiation of algebraic functions. Okay, so we have here the learning competency. Apply the differentiation rules in computing the derivatives of an exponential and logarithmic functions. Okay, so the objective here, apply the rules of differentiation in finding the derivatives of an exponential and logarithmic functions. A derivative of an exponential function with base e. If f of x equals e to the power of u, then the first derivative of x is equal to e to the power of u times the first derivative of u, where u is the exponent of the exponential function with base e, and first derivative of u is the derivative of the exponent. Okay, so we have here the example. The given is f of x equals e to the power of x. First thing to do is you are going to identify what is the value of e to the power of u and the value of u so that you can find the first derivative of u. Okay? Since the given is f of x equals e to the power of x, so therefore the value of e to the power of u is e to the power of x. And the value of u is the exponent, which is x. So solving for the first derivative of x, remember that to find the derivatives of the given function from algebraic function, so the exponent of x is 1 and the base is 1. So exponent multiplied by the base, 1 times 1, the result is 1. And copy the variable x, then subtract the exponent of 1 minus 1. Since 1 minus 1 is 0 and x to the power of 0 is equal to 1, so therefore the value of the first derivative of x is 1. So solving for the first derivative of the given function of f of x equals e to the power of x, so the value now is e to the power of x multiplied by 1. The result is e to the power of x. Okay, so we have here the second example. If h of x equals e to the power of 5x plus 3, again, you have to identify what is the value of e to the power of u and the first derivative of u. So since the value of e to the power of u is e to the power of 5x plus 3, and u is 5x plus 3, and the derivative of 5x plus 3 is 5. Okay, so solving for the first derivative of h of x, so that is e to the power of 5x plus 3 multiplied by 5. So the result now is 5 e to the power of 5x plus 3. Okay, for letter C, we have g of x is equal to e to the power of x squared. Identify what is the value of e to the power of u. The value of e to the power of u is e to the power of x squared, and the value of u is x squared. Solving for the first derivative of x squared, again, you have to find the value of the exponent, which is 2, multiplied to the base, which is 1, that is 2. Then copy the variable x, subtract the exponent by 1, 2 minus 1, that is 1, so x to the power of 1. So the first derivative of u now is only 2x. Then solving for the first derivative of the given function of g of x, so that is e to the power of x squared times derivative of u, which is 2x. So therefore the answer now is 2x e to the power of x squared. Okay. Next is the derivative of an exponential function with base a. If f of x equals a to the power of u, then the first derivative of x is equal to a to the power of u multiplied by first derivative of u multiplied by ln of a, where u is the exponent of any exponential function. First derivative of u is the derivative of the exponent, and ln of a is the natural logarithm of base a. Okay, so we have here the example. If f of x equals e to the power of x, again, identify what is the value of a to the power of u. From the given, the value of a to the power of u is e to the power of x. Then the value of u is the exponent, which is x, and the first derivative of x is 1. Then multiplied by ln of a. The value of a is the base of the given, which is e. Okay, so therefore, the first derivative of the given function of e to the power of x is e to the power of x times 1 times ln of e. So remember that ln of e is equal to 1. So you have to multiply 1 times e to the power of x. The result is e to the power of x. In this example, you can see the derivation of the formula being used in the previous rule, where ln of a was omitted, and the reason that ln of e is equal to 1. Okay, we have here the second example. If f of x equals 3 to the power of x, again, the value of a to the power of u is 3 to the power of x, and the value of u is 3x, so therefore the first derivative of u is only 1. Then the value of a is 3. So substitute to the given first derivative equation. So first derivative of x is equal to 3 to the power of x times 1 times ln of 3. So when you are going to multiply that one, the result is 3 to the power of x ln of 3. Okay, next is the given is f of x equals 9x cubed. Again, identify the value of a to the power of u, which is 9x cubed. And the derivatives of u from given u is x cubed, so derivatives of u is 3x squared. Then the value of a is 9. So substitute, it becomes 9x cubed times 3x squared, because 3x squared is the value of the first derivative of u, and multiplied by ln of 9. Remember that we cannot multiply 9x cubed and 3x squared since they are different exponent. Okay, next is the derivative of a natural logarithmic function. If f of x equals ln of u, then the first derivative of x is equal to the first derivative of u over u, where ln of u is a logarithm with base e. U is the argument of the logarithm of first derivative of u is the derivative of u. Example, find the derivatives of the following functions. If f of x equals ln of x, okay, identify the value of u, which is x, and the first derivative of x is 1. So substitute the given function of first derivative of x, which is first derivative of u over u, so therefore the value now is 1 over x. Next is g of x equals ln of the quantity of x squared minus 5x. Again, the value of u is x squared minus 5x, and the first derivative of u is 2x minus 5. Okay, substitute the given function of the first derivative, that is first derivative of u, which is 2x minus 5, and the value of u is x squared minus 5, so therefore the first derivative of g of x is 2x minus 5 over x squared minus 5. For letter C, we have h of x equals 8 ln of 5 minus 9x. The value of u is 5 minus 9x, and the value of the first derivative of u is only negative 9. Okay, so solving for the value of the first derivative of h of x, that is equal to 8 multiplied by first derivative of u over u, which is equal to 8 times negative 9, because the value of u is negative 9, over 5 minus 9x. Then multiplied 8 times negative 9, the result is negative 72 over 5 minus 9x. Okay, so next is called the derivative of a logarithmic function. If f of x equals log of u to the base of a, then the first derivative of x is equal to the first derivative of u over u ln of a. Remember that a is the base of the logarithmic function. Okay, so we have here the example. Find the derivative of the following functions. The given is log of 3x plus 4 to the base of 2. Again, identify the value of u and the value of a. The value of u is 3x plus 4 and the value of a is 2. Okay, so first derivative of u of 3x plus 4 is only 3. And the value of a is 2. So therefore, the first derivative of the given function is equal to 3 all over 3x plus 4 ln of 2. Okay, letter B, we have given is 7 log of 5x to the base of 3. Again, the value of u is 5x, and the derivatives of u, or the derivatives of 5x, is only 5, and the base is 3, or the value of a is 3. Okay, so we have here the first derivative of the given function, that is 7 multiplied by 5 over 5x ln of 3. Remember that 5x ln of 3, the 5x there is also a monomial. So we can cancel the numerator of 5 and the denominator of 5. So the remaining value now is 7 times 1 over x ln of 3. Then you are going to distribute the value of 7 to the numerator. It becomes 7 all over x ln of 3. Okay, so we are now in what's more. Okay, so we have here the direction. Find the derivatives of the following functions. So you are going to solve this one to find or to use the previous lesson from the algebraic to exponential and logarithmic functions. Okay, so that's all. Thank you for listening, and do not forget to click the subscribe